All right. Okay, so here is the uh, video on relationships. So we're going to talk about the relationships that exist in the equation F net equals MA. All right. So the first thing we're going to do is we're just going to look at which ones are inverse and which ones are direct. And then we'll start looking at some applications of those different things. So if we want to determine the relationship, let's say between mass and acceleration, right? What I need to do is I need to isolate the other variable in the equation, which is already done for us. F net is already isolated, and we're going to hold it constant. So now that it's held constant, what we're going to do is we're going to start looking at, okay, so what happens if I change one of these others? So if I change mass, let's say I double the mass, to keep net F net the same, what do I have to do to the acceleration? Well, the answer is I would need to divide by 2 so that those 2's cancel. What that means is as mass goes up, acceleration goes down. Vice versa, if I divided mass by 2, I would have to double the acceleration so that they would cancel to keep the F net the same. So what we've got here is a very clear situation. As mass goes up, acceleration goes down. As mass goes down, acceleration goes up. And so this would be an inverse, this would be very much an inverse relationship. Okay. Now, let's say we don't want to know the relationship between mass and acceleration. We want to know the relationship between, let's say, F net and mass. So if we want to know that relationship, we need to isolate the acceleration. So to do that, we're going to solve for the acceleration, divide both sides by mass, and we end up with A equals F net divided by M. Now, if we go take a look here and we start changing things again, if I double the F net, I will have to double the mass, so those 2's will cancel, so that I keep my acceleration the same. Likewise, if I decrease F net by multiplying by a half, I will have to do the same thing to the mass to keep those the same. So in this case, as F net goes up, mass goes up by the same amount or factor. As F net goes down, so does mass. It goes down as well. So this is a very clear case of a direct relationship. So let's say we want the third and final relationship here. So we want the relationship between F net and acceleration. So what we need to do here is isolate M. So we're going to solve for mass and divide the acceleration over. So mass is equal to F net divided by acceleration. So doing that, if we double the F net, what do we have to do to the acceleration to keep mass the same? We need to double so that they cancel. If we need to half the F net, we half the acceleration. Again, we do the same thing. This is yet another direct relationship. So the trick here is if we take a look here and we look at the math, when the equation is written like so, and the two variables we're studying are multiplied together, they have an inverse relationship. Whereas when we rearrange the equation and we get something like this, and the two variables we're looking at are divided by each other, then we get the direct relationship. So this is a shortcut you can use as long as you are properly isolating the variable you're keeping constant, and then the two variables you're looking at, you can easily look at those. Now, I'm going to clear this real quick, and let's see if we can talk about what are the different relationships or different little things that we can do to these things. So, if, for instance, I wanted to, let's say I'm going to do two things at the same time, all right? I'm going to double the mass and I'm going to double the acceleration. Well, if you remember, they both have a direct relationship with F net. So that means we could also just do the math here. If we double this and we double that, 2 times 2 is 4, we actually quadruple the net force. So also with the relationships, if we're looking at relationships, we double the mass, we double the net force, then we double the acceleration, we double the net force again, so we get 4 times. If we wanted to, say, do a different change, let's say we wanted to half the mass and double the force. So what would that do to the acceleration? Well, if you remember, the relationship between mass and acceleration is inverse. So if I half the mass, that means I need to start by doubling the acceleration, but I also doubled the force, which has a direct relationship, so I have to double it again, so we have to multiply by 4, and so we put the 4 there. And if you notice, the math works out. The half times the 4 still equals the 2. So there's a couple of different ways you can do this. You can look at the relationships directly, or you can plug the numbers in front and see what the math says it has to be. Either way, you'll get the same answer.